Basic concepts of periodic properties we will discuss in this video. Periodic properties is a very big chapter, but actually it mainly deals with three things, namely ionization energy. IE means short form IE, ionization energy, or you can say it ionization potential, and it is electron affinity, EA, and it is nothing but the electronegativity. So ionization energy or ionization potential, what does it mean? It means if any element removes one electron to form a cation in its gaseous state, the amount of energy absorbed by this element is known as ionization energy. That means we can say that the minimum amount of energy that is required by an element in gaseous state to remove its valence electron to produce a cation in its gaseous state. And as energy is required here, so ionization energy must be positively charged because it is endothermic process. If any element does not have a tendency to remove its electron easily, then its ionization energy will be increased. Say for fluorine, say for oxygen, say for boron. They are non-metals. So non-metals have the ability to retain their electrons, accept their electrons. So it has less tendency to remove electron easily. That is why they will have higher ionization energy. But metals, say I am sodium. So sodium has a tendency to remove electron because the nearest noble gas present in sodium, that is neon, 10, and sodium has the electron 11. So 11 will have a tendency to easily get converted into neon. So it will remove an electron easily. So sodium will have less amount of ionization energy. Okay. So if any element does not have a tendency to remove electron, that means more amount of ionization energy is required. And if any element has very easily has the ability to remove electron, that means low amount of energy is required, so it will have low ionization energy. But if you want to remove an electron from this cation, then what is happening? Then it is second ionization energy, it is first ionization energy. Obviously it is electron deficient, so it needs electron, and you are trying to remove this electron from this cation. So ionization energy will be increased because it will have no tendency to remove electron, it will have a tendency to gain electron, because any positive charge has a tendency to gain electron to get neutralized, and any negative charge has a tendency to donate electrons to get neutralized. Okay, so obviously we can write here IE2 much greater than IE1, IE3 greater than IE2. So this is all about ionization energy and ionization potential. Metals will have low ionization energy, non-metals will have high ionization energy. Now electron affinity. Electron affinity is nothing but, that is the reverse process. If X gains one electron, then energy will be released. Energy will be released. That is why it is exothermic process. That means the minimum amount of energy that is released when one electron is added to the valence shell of an electron to produce an anion in its gaseous state. Why gaseous state? Because gaseous state is the most unstable state and its reactivity will be in the highest order. Okay. So if non-metals, we know that non-metals have tendency to gain electrons, that means it will have more electron affinity. So if any element has a tendency to gain electrons, that means it will have high electron affinity. And if any element has a tendency not to gain electron, that means metals have a tendency to remove electron, they don't have a tendency to gain electron. That is why metals will have low electron affinity and non-metals will have high electron affinity. And electronegativity is what? Electronegativity, it is not energy, because they are energy, they can be calculated in joule, calorie, kilojoule, kilocalorie, all of these units. But electronegativity is the property by virtue of which any element can attract the bonded electrons towards itself. It is inherent property. That means HCl is there, chlorine is more electronegative than hydrogen, so these electrons are more attracted towards chlorine. So it is known as the electronegative property or electronegativity of chlorine. If instead of chlorine there is fluorine, bromine, iodine, all of these will have the arrow towards them. Okay, so now we need to know that how this ionization energy, electron affinity, electronegativity varies with the proper periodic, with the period, with the group, with the period, with the group. Okay, so first of all we need to know, this is, you know, the horizontal line means period, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and here neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Suppose 1 to 20 elements I have written, their atomic numbers, you know, 1 to 20 elements, but actually this gap is quite large because it is group 1, group 2 and it is group 13, but just to make you understand I have written like this. Okay, so this is period and this is group, you know. The elements belonging to same group, they will have similar properties. That means fluorine 1s2 2s2 2p5, chlorine 3s2 3p5, bromine 4s2 4p5, and below that iodine 5s2 5p5. So their electronic configurations are same. Nitrogen 1s2 2s2 2p3, phosphorus 1s2 2s2 2p6 3s2 3p3. That means 2s2 2p3 and 3s2 3p3 have similar property, similar electronic configuration, so they are belonging from same group. Okay, so if we move along a period from left to right, then what factors are to be observed? That is number 1, you need to memorize, because in book it is written in illustrative way, you need to follow these tricks. If we move along a period from left to right, then atomic size decreases. Why? Because number of electron increases, that means effective nuclear charge increases, that means atomic size decreases. So the distance between nucleus and the valence electron decreases. So attractive force between nucleus and the valence electron increases. So the element does not have a tendency to remove its electron easily. So I have discussed ionization energy will be increased, because if any element does not have a tendency to remove electron, then more amount of energy is required. So atomic size decreases, that means attractive force between nucleus and the valence electron increases, So ionization energy increases, and as ionization energy increases, that means the element does not have a tendency to remove electron, so it must have a tendency to gain electron. That means electron affinity value increases. So obviously if it gain electrons, that means the power of attracting power of the electron towards itself increases, so electronegativity also increases. And we know that metals are electron donor, electron remover, and non-metals are electron gainer. So here metallic property, obviously we can say that metallic property decreases, downward arrow means decreases, okay, and non-metallic property increases. We know metallic oxides are basic in nature. Suppose you have taken sodium. So sodium plus O2, what will form? Na2O. Na2O plus H2O. Na2O plus H2O. What will form? NaOH. So metallic oxides are able to form bases. So metallic oxides are basic. And if you take say for carbon, CO2 plus H2O, what will form? Carbonic acid. That means non-metallic oxides are acidic. From phosphorus you can get phosphoric acid, sulfur you can get sulfuric acid, all of this. So metallic oxides are, you need to memorize, basic in nature, and non-metallic oxides are acidic in nature. So if metallic property decreases, then the basic nature of the oxide decreases and acidic nature of the oxide increases, reverse. And the last but not the least, that is number 8 point. Number 8 point is, if I gain one electron, that means I am getting reduced. So if from period, along a period, if we move from left to right, then what is happening? Electron gaining power increases. That means the element itself getting oxidized. So it's itself getting reduced. So its power or oxidizing power increases. That is why we can write here reducing property or reducing power decreases, and that means oxidizing power increases, okay. But there is some exceptions we will discuss. So if we move along a group or down a group from top to bottom, then what is happening? This factor will be reversed. That means atomic size increases, so attractive force decreases, so it will have a tendency to remove electrons. That is why ionization energy decreases, electron affinity decreases, metallic property increases, non-metallic property decreases. So along a group down, if we move down a group, then the reverse factor will be observed. So if the question comes, compare the ionization energy of nitrogen and oxygen, then what will be your answer? So according to my trick, you can say that ionization of energy of oxygen is expected to be greater than nitrogen, as it is as we move from left to right, oxygen is right to nitrogen, but actually the reverse case is observed. That means ionization energy of nitrogen is expected to be less than that of oxygen, but actually it is not true. In practical, we have seen that ionization of energy of nitrogen is greater than ionization energy of oxygen. Why? Because nitrogen has the electronic configuration like this. So in p orbitals, how many electrons can maximum it can retain? 6, because p orbitals have 3 subshells, so it is half filled. But if oxygen, you can see it is 8, so it is 2p4. So according to Hund's rule, it will be filled like this: 1, 2, 3, then 4. It is not like 2, 2 and 1 orbital is vacant. 1, 2, 3, another is 4. So here repulsion occurs, because in one room, in one subshell, 2 electrons are there, there will be repulsion. But they are free. Hund's rule, we know that from Hund's rule that full filled orbitals and half filled orbitals are more stable than any other configurations. That is why here oxygen has a tendency to lose electron to be like nitrogen, but nitrogen is stable. So why it will remove any electron? So it does not remove any electron easily. That is why I have told you, if any element does not have a tendency to remove electron easily, that means its ionization energy will be increased. So nitrogen will have higher ionization energy than oxygen. The same question, important question, also comes in your board exam. That is why the ionization energy of beryllium is greater than boron. Though beryllium is placed right, boron is placed right before after beryllium. So if we move along a period, then ionization energy increases. So the reverse order is expected, but actually the order is like this. When trick is not applied, trick is applied for 80% cases. When trick is not applied, then we need to follow the electronic configurations. That means beryllium means 1:2s2, boron means 1:2, 2s2, 2p1. So it is full filled, but it is neither half filled nor full filled. So boron has a tendency to remove an electron to be like beryllium, as beryllium is full filled. But as beryllium is full filled, it does not have a tendency to remove any electron from this orbital. This is one reason. And the next point you can also add, that is 2s orbital is much more closer to the nucleus than 2p orbital. So it is very difficult to remove an electron from 2s rather than 2p. So beryllium has less tendency to remove electron. That is why ionization energy of beryllium is more than that of boron. Okay. Now if PbO, ZnO, Al2O3 is given to you, and the question comes, what is the nature of these oxides? So you have seen metal, sir told metallic oxides are more basic, that means they are basic, but actually they are amphoteric in nature. Why? Because when ZnO reacts with HCl, it will form salt and hydrogen, salt and water, acid, base, salt, water. So it shows its basic nature. And when ZnO reacts with NaOH, it will form Na2ZnO2 and H2O. That means it shows its acidic nature, because acid plus base, you know, salt and water. So ZnO has both the ability. So you need to remember this trick, that is sab jan ki aas suno Prabhu Allah. This is the trick. That is, sub means Sb, this is zinc, ki is just connectivity, As, Sn, Pb and aluminium. These are metallic oxides, but their oxides are not basic, their oxides are amphoteric in nature. So metallic oxides are basic, non-metallic oxides are acidic in nature, but these oxides of this metal, if you follow the trick, oxides of this metal will be amphoteric. They will be amphoteric in nature.